Hey guys, welcome back. The first thing that we're going to talk about in this lecture is the Pythagorean identity. So let's set up the picture. We have a point on the unit circle, and from that point we can construct a right triangle such that this leg is x units and this leg is y units and the hypotenuse is 1. And then we have this angle here, right? This angle, we'll just call it theta, right? This angle right here is theta. Okay. So recall that the Pythagorean theorem tells us that we could take the square of these sides, sum them, and get the square of this side. So what that gives us is this equation here. X squared plus y squared is equal to 1 squared, which is just 1. But recall that at this point here, if we look at it, like we know that that's x comma y, right? X units to the right, y units up, that's xy. But from the last video, we know xy is also cosine of theta comma sine of theta. So knowing this here, we can rewrite this equation in terms of cosine and sine. So this gives us cosine squared theta plus sine squared of theta is equal to 1. Now you might be unfamiliar with this notation. I put the 2, the exponent 2, in between cos and theta. Well, that's just standard notation for raising any trigonometric function to some power, right? This is the exact same thing as saying this, cosine of theta, all of that squared plus sine of theta, all of that squared is equal to 1. Same thing, but this is more common. Okay, so that's Pythagorean theorem. Now let's use it. So here's an example. Suppose that, let me just set up the problem. If cosine of t is equal to 24 over 25, and t is in quadrant 4, then find sine of t. So that's the problem. Just looking at this, it's kind of difficult to see what's going on. So I really recommend with these types of problems, when you're given some trigonometric function and you know it's a ratio and you know that the angle's in some quadrant, but you don't know what the angle is, it's really important to just go ahead and construct the unit circle and try to get a good visual representation of the problem itself. So that's what we're going to do. So let's go ahead and construct the unit circle. Or actually, no, let's just construct the xy plane. I think maybe that's a better approach. So here's the xy plane. And we know that we have some angle t, and it's in quadrant 4. So quadrant 4, this guy here in the lower right. So angle t, we haven't been told if it's positive or negative, so we're going to assume it's positive. We're always going to assume an angle is positive unless otherwise stated. So to get to quadrant 4, we go in this direction, and so this is angle t. So let's go ahead and construct a triangle here. And why am I constructing a right triangle? Well, let's go back. We've got this point here, right? Like anytime we're talking about trigonometric functions, we can always consider a triangle situated on the xy plane. But because in our case, we have some unknown angle t, right? That just means that our point that we're considering is somewhere over here, right? And this little segment here, the hypotenuse, the soon-to-be hypotenuse of our right triangle is here, right? But in this case, our hypotenuse is not 1, right? Our hypotenuse is actually 25, because recall that cosine of t in general is x over r, right? Where x is this distance here, and r is the hypotenuse of our right triangle, and then this is obviously y. So if cosine of t is x over r, and cosine of t is also defined as 24 over 25, then what does that mean that x is equal to? Well, this is 24, and our radius of this, circle that I didn't construct, but we can imagine that we have a circle, right? Like, can't we pretend that we have some circle here, right? Where this point here is the point on the circle, and the radius of the circle is, well, it's 25, right? By the definition. So the radius is 25. Okay, great. So what we just accomplished was we constructed an image that represents the problem. And that's really going to help us accomplish the goal of solving the problem. And we want to find sine of t. Well, sine of t, remember, sine of t, here's the definition. Sine of t is equal to y over r, where r is the radius. Well, what is y? Y is unknown, so we'll leave that alone. And r is 25. So our job is to find this missing side of the triangle, right? So let me just reconstruct the triangle down here so we get a better idea of what's going on. And you probably already have it. If you already know what's going on, then go ahead and just continue with the problem. So here's our triangle. I'm going to try to orient it the same way. It's a right triangle. The hypotenuse is 25, also known as the radius of our circle. This leg here is 24, and we want to find y. Well, Pythagorean theorem. In other words, we're using the Pythagorean identity. So the Pythagorean identity, recall, x is using the trigonometric functions, but in this case, we could just use the regular. We could just say this right here, 24 squared plus y squared is equal to the hypotenuse squared, right? And I'm going to skip some steps. I trust that you know how to solve for y in this case. Turns out y is equal to plus or minus 7. And the reason that I say plus or minus, because remember, we have to take the square root eventually. So we arrive at this junction. Which sine value do we choose? We have to choose one. Well, let's go back. Where is the angle located? Our angle is located in quadrant 4. Okay. We're in quadrant 4. That means that our x values are always going to be positive, right? Because we're going to the right. Our y values are actually always going to be negative because we're going below the x-axis. So therefore, we're actually going to pick y is equal to negative 7. That's the y value that we want. And you might ask yourself, well, is the radius ever negative? Well, to that I say, does it make sense to have a negative radius on a circle? And the answer to that is no. So radius is always positive, right? The position of the angle on the xy plane tells us whether or not we have, it helps us determine sine values. So y is negative 7. Therefore, we have sine of t. And again, it doesn't matter. We don't know where t is, and it doesn't really matter where it is. we just know that it's in quadrant 4. Like, that's important. So sine of t is equal to -7 over 25, right? Because we know that sine of any angle, when we're talking about a point on, on a circle that's at the origin, it's always equal to the y value over the radius, right? And in this case, what is our y value? Well, it's -7, and the radius is 25.